Hi, this is Sebastian Fischer. The OpenML-CTR23 is a curated tabular regression benchmarking suite, and it will be presented as a workshop paper at the AUTOML Conference 2023 in Potsdam. This was joint work with Liana Harutunian, Matthias Feurer, and Bernd Bischl. The main contribution of the paper is the creation of this benchmarking suite, which is a collection of high-quality datasets that can be used to compare regression algorithms. So in total, there are 35 curated regression problems. These are datasets annotated with metadata, like which features to use and which variable to use as the target variable. In addition to that, we also provide predefined resampling splits, like cross-validation or holdout for all 35 problems. These are available as a collection on OpenML with ID 353. The inclusion criteria are as follows. So we adapted some of them from the CC18, which is a curated classification benchmarking suite on OpenML. There are between 500 and 100,000 observations, less than 5,000 features after one-hot encoding. The data is not sparse. The data has IID, or specifically that there is no time series or grouping, which requires a special care during resampling. There is a clear description of the data available, and this description is then also included on OpenML. And the dataset is it's possible that the dataset is simulated, like there are some physical simulators, but we remove datasets that are simplistically generated, which we here call artificial. Further, the dataset is not a subset of a larger dataset. We also introduce a few new criteria, namely that the target variable has at least 5 different numeric values, because we are here dealing with regression and not classification. And the task cannot be solved with a simple linear model. Furthermore, we removed some datasets for ethical considerations. So whenever we were not sure that there might be some problems, we also excluded the dataset. And we ensured that we did not find any restrictions on data usage. So most of the datasets actually have a license. In some cases, when we thought that the dataset was clearly intended for scholarly use, but did not have a license, for example, because it's an old dataset, we still included it here. To check whether the suite is challenging enough to differentiate between algorithms, we ran a first experiment that compared 5 models of different capacity, namely XGBoost, which we tuned, untrained random forest, a generalized additive model, a ridge regression, where we only tune the lambda parameter, and a regression tree. We averaged the ranks over all 35 problems and display the critical difference plot here, where we see that XGBoost is number 1, followed by the random forest and the GAM, and finally the ridge regression and the regression tree. From that, we conclude that the datasets are sufficiently challenging to be able to differentiate between models of different capacity. Finally, I want to take the opportunity to briefly talk about the project in the context of which this benchmarking suite was created. This project is MARDI, which stands for Mathematical Research Data Initiative. This is an NFDI consortium for mathematics, where the NFDI is a big German project and stands for National Research Data Infrastructure. And its purpose is to provide research data infrastructure for science. The mission of MARDI is to establish mathematical research data infrastructure, to set standards and confirmable workflows for certified mathematical research data, and to provide services to both the mathematical and wider scientific community. The FAIR criteria, which stands for findability, accessibility, interoperability, and reusability, are the guiding principles for what we do in MARDI. And we also have a website, so if you're interested, you can learn more about it here.